Okay, hello everybody. Let's do a demo of Jenkins X version 3. Oh, exciting. I'm going to turn off my video because my internet's slightly ropey, and I'll share my screen and we'll see how this goes. So let me start sharing my screen. 1 second. Hang on a second. I'm going to have to rejoin. 1 second.
All right, while James is doing that, what I will say is that we are starting a testing and platform integration SIG. And it will be starting not this Friday, but the following. The goal right now is for 4 p.m. in the UK, which is 1500 UTC, I believe. And it is on the Jenkins X calendar. And we have a mock-up of the, well, we have the start of the repo for the SIG, but that is open for PRs and additions. So if you're interested in being involved in the SIG or you would like to contribute to it in some way, please look on the Jenkins X community repo under the Jenkins X org, and you will find out more about that SIG, and you can check on the Jenkins X calendar to find out the times for it.
Sorry about that, Cara. It's the first time I've ever shared my screen on my new laptop, so I had to restart Zoom to share. Okay, let's do a quick demonstration, well, quite a long demonstration of Jenkins X version 3. So I'm going to start with absolutely nothing, and I'm going to create a new cluster and install Jenkins X from scratch, and then we're going to use it. It's going to take a little while to boot all this stuff up. It takes a little while for these things to happen. So while the various different steps are running, I'll describe what's happening behind the curtain and show you the source code and stuff. So if you go to the 3.x version of the website and you click on the Getting Started page, it describes how you need to install the new version of the JX command line tool. And then it asks you to pick which kind of cluster you want to start with. So do you want to use Google, do you want to use Amazon, or do you want to use Minikube? I'm going to start with Google. We've tested it a bit more on Google, but EKS is fairly close now. And the first thing you do is create a new Git repository. So if I click on this link, it opens a new window, and it's using github.com's ability to create new Git repositories from templates. So I'm going to create a new Git repository. I'm going to call it Terraform Demo 4. And I'm going to make it private just in case I accidentally check in something secret. And I'm going to click Create from Repository. So now GitHub is going to create a new Git repository for me. There we go, it's almost there. And then I need to follow the rest of these instructions, which basically say clone the Git repository and cd into the clone, and then follow this guide on how to do the next bit. So if I clone this Git repository, git clone, and then cd into JX3 Terraform 4. So here's the source code that we just cloned. There's a Helm file that defines all the charts to install, the requirements file and stuff. If I check back on these instructions, it says I need to create an environment variable for the GCP project. If you're using Google, you need to define which project you wish that to be. You wish your cluster to be created inside. So I've got a project name there already. So there's my environment variable. Then you run this little configure script which modifies the Terraform file for you. Then you run the Terraform apply, which is this script here. There we go, Terraform apply. This is now going to download all the various Terraform modules and stuff, and do the Terraform stuff to decide which resources need to be created. So from a very high level, it's going to be a Kubernetes cluster called GKE on Google. So a Kubernetes cluster is going to create some cloud service accounts for IAM roles and stuff like that, so that we can give karma to pipelines to be able to write to the container registry and buckets and so forth. And it's going to create a couple of buckets, and that's about it really. So it's going to create a bunch of cloud infrastructure. This takes a couple of minutes, and fairly soon it should get to the run part. What Terraform does is whenever it runs, it decides what needs to change and then prompts you and tells you, and then you get to review all the things it's about to do. So you can see, you can kind of scroll through this output and see which service accounts are being created, which buckets are being created, which Kubernetes cluster. There's some workload identity stuff going on there. There's some service account stuff. There's some IAM roles, there's a KMS keyring, and so on and so forth, and the Kubernetes namespace and stuff. So you can review all these things at your leisure, and then when you're happy, you type yes, hit return, and then Terraform is going to do its magic. It's going to go create all of these Kubernetes resources, and then we'll be able to play with it when it's done. So the three, you create the Git repository, then if using Terraform, you run the resources, and then the final step is you do this thing, you make any changes, because we've actually modified a couple of local files, and then you run the operator, which we'll do in a minute. So Terraform tends to take about kind of 3 or 4 minutes. Just while that's running, I'm just going to look in a separate terminal, JX3, Terraform, demo 4. If I do a git status, we'll see we've modified the Terraform file. If I do a git diff, we'll see we've basically just added our project ID. So we've added our project ID so it knows where in Google Cloud are we going to create this new cluster. So I can now do a git commit, -n GCP project, and git push. So we've pushed all the changes into Git, and we're kind of ready now to boot up once Terraform's finished. Just while Terraform's chugging along, I'll leave this window open and we can kind of see when it's finished. It's going to finish in a couple of minutes. I'll just walk you through the Git repository. So this is the Git repository we've just created. I can shut the old windows down. I don't need them anymore. Now, those of you who've used Jenkins X before will maybe have seen the Terraform main file, which is the thing that configures things like the project ID and the modules to use to install Terraform. It's also got the instructions of what to do next after Terraform's run, which is this page which walks you through how to install the operator, which is basically that one command line, which I'll do soon once Terraform's finished. There's a few other things in this Git repository that might look a little bit different. So you've maybe seen the Jenkins X YAMLs before, and the JX requirement hasn't really changed much. The JX requirements is a blob of YAML that defines what's your build pack, which Git repository to use, which Docker registry or container registry you're using, which Git provider you're using, what environments to make, what ingress are you using, how are you storing your secrets, and various other things like that. So the requirements file is the same as it was in version 2. The big change though is we have a Helm file.yaml file now. So the Helm file is a blob of YAML that defines all the charts to install in Kubernetes. So here's all the different charts that we install by default. So you might recognize, if you've used Jenkins X before, there's Tecton, there's Lighthouse, there's Nexus. There's Chart Museum as well. Now this is just a blob of YAML you can remove and add whatever you like. So if you didn't want Nexus, just delete that line. If you didn't want Chart Museum, just delete that line. Add more lines for other charts you wish, and so forth. We're using Vault in this installation. So here's the stuff for Vault. We're using the Vault operator, and then this defines a Vault instance. So Vault operator is an operator that looks for Vault custom resources. When it sees a custom resource for a Vault, it makes a Vault pod, and this Vault instance is a single Vault CRD, basically, that triggers the creation of an actual Vault. So the operator looks at the CRD from this chart and boots up a Vault for us, which is really nice. So you can play around with all of these things. Notice there's a list of all the different chart repositories that we're using. You can use any chart repository that you find on the internet. You can use any internal chart repository you like. And charts can reference different repositories. So it uses a kind of a prefix. The prefix maps to one of these things. So if you see we're installing Jenkins X Lighthouse, that's in this Git repository. This chart repository. So that's the Helm file. You might notice there's no versions in this Helm file yet. What happens is when you boot things up, Jenkins X resolves the default versions and the default namespace of all these charts using the version stream. And we've always used the version stream as a way of keeping track of what versions of things work well. The Terraform is just completed, so that's great. So this is the line, if you wish to use the command line to connect to this cluster, you just copy and paste that into a terminal and you're connected. By default, Terraform connects to this cluster for you. So if I do kubectl get namespace, we should be now in this new empty cluster. There we go. There's no JX namespace or anything. If I do what was I just about to? Oh yeah, if I do jx-ns-b, we'll see this is the same cluster as this one. So we're in envoying Basilisk, the most awesome cluster name I've ever seen. So we've got an empty cluster, so we're now ready to boot this up. So we have no JX namespace, so now what we do is we type JX admin operator. And this is a new command which installs something called the git operator. Let me get it going first, and then I'll describe what's actually happening. So it's asking the Jenkins X git operator needs three things. It needs to know the git URL, which it knows because we're inside the git clone. It needs a username and a git token to be able to execute pipelines, create pull requests, create releases, and those kind of things, and do commits. So I'm going to use my personal username. It's now asking you to click on this URL to create a new token. I'm actually going to copy and paste one in I made earlier. So boom, we've now run the JX admin operator. It's doing a quick Helm repository update to grab the latest Helm chart, and it's going to do a Helm install any second now. So all this command really does is run a Helm install, passing in the URL, the username, and the token. And there we go, that's the Helm command that's just running. So it's Helm upgrade -- install, which does an install or upgrade depending on if it's been installed before. It passes in the URL, the git URL to my git repository. The username is masked the password, which is nice, and it's got the namespace, and this is the name of the chart, so git operator. So it's installed the chart, which is great. You can see that the git operator is pending, so it's basically Kubernetes is downloading the image, and the pod should start fairly soon. Then this git operator, all it really does is pull this git repository, and whenever there's a change, or at the very first time it's installed, it's going to run a job inside the Kubernetes cluster. So one big change from Jenkins X version 2 is we boot up Jenkins X from inside the Kubernetes cluster. We don't run anything locally. We don't need any secrets locally. We don't do any of that kind of stuff locally. All we really do locally is work with Git repositories. Applying of Kubernetes resources or generating stuff is all done inside the job in Kubernetes. So you'll see that the operator's running, the operators realize we need to run a boot job. This is the name of the job, and it's now created a pod called JX boot. That boot is then starting up. It's going to be downloading some container images and whatnot, and fairly soon we'll see some output from this stuff. Now, while that's running, I'm going to start up octant. So let's start up octant. Oh, you can see there's some output started. So the pipeline's running. It's basically resolving all the versions in that Helm file I showed you a few moments ago, and it's going to start processing the boot stuff in this boot job. If I look in octant at the pods, we'll see we currently just have two pods in the JX namespace. So we've got the git operator and the boot job. And the boot job is now Git cloning that Git repository, analyzing all the charts, defaulting any missing namespaces, any missing versions. It's then going to apply those resources into Kubernetes and create everything. So we'll leave this going. It takes a few minutes, maybe 5 minutes or so. So I'll leave this window up. You should eventually see more pods arrive once things get a bit closer. And just while that's going, I'm just going to show you a bit more of how all this works. So we've always used version streams in Jenkins X. And a version stream is really a collection of metadata and config files and stuff that relate to Helm charts, Git repositories, container images, CLI binaries, and various other things. And you'll notice that whenever you create a brand new Git repository for your cluster, we have a version stream folder inside. And this is you basically get your own copy of the version stream. And the version stream has a whole bunch of different directories. It's kind of documented in this README if you want to kind of noodle the docs. But we have a charts folder, and inside the charts folder, we have configuration for every different chart that we ever use in Jenkins X. So if I look inside the Jenkins X folder, and I pick one at random, let's pick Lighthouse. So there's Lighthouse. We have a little default YAML file, which says, by default, use this version number of the Helm chart. So if you don't specify any specific versions in your Helm file.yaml, it will default to use this version of the chart. So it means we can have a standard shared Git repository with all the versions of things which we know works. then whenever a new chart comes out, we can do a pull request on the version stream, test out that new version of the chart, and if all the tests pass, we can then merge in that version change. Historically, we found all kinds of issues with just using whatever the latest container image. So we always make sure we lock down all the versions of the container images or the charts, and we use the version stream for this. Another thing we do with the version stream is we allow you to configure default namespaces for things. So if you look at the stable and Nginx and look at the defaults here, we've defined that by default, we'd like to put Nginx in the Nginx namespace. Typically, Nginx is shared across many different things, like Jenkins X, and maybe Tecton, and maybe something else, and maybe your apps, and maybe some microservices. So we've made the decision to put Nginx in some namespace separate to the other Jenkins X pieces. Now, whatever the defaults are in the version stream, you can always specify these exactly yourself in the Helm file. As Jenkins X runs, let's see if it's resolved it. Oh yeah, it has. Resolve step. So you can see all these charts now have exact versions. So you can see there's the version of the Kubernetes external secrets. We're using 4.0.0. We're using the secrets info namespace to create the Kubernetes external secrets chart. If we scroll down, there's Nginx. We can see there's Nginx, and that's in the Nginx namespace. And here's Tecton, and that's in the JX namespace. And there's Lighthouse in the JX namespace. Now you can always change these values yourself. So any of these, any chart, you can specify exactly which namespace you want them to be in. You can specify the version explicitly and so forth. Now the eagle-eyed amongst you might have noticed this other thing here. There's this optional values file. And this is a Helm file feature. The Helm file allows you to pass in values.yaml files. So there's an example of values.yaml file. Or you can use a values.yaml.go template. So this allows you to pass in a values YAML into Helm. Now Helm has a configuration system that lets you pass in YAML to override values in the templates. So things like specifying the number of replicas, specifying additional environment variables or additional labels or annotations or whatever. Now, a lot of charts need various bits of configuration for things like ingress, the domain name you wish to use, whether or not you're using TLS or not, and so forth. And rather than making it so that every user needs to configure every single chart by hand with all these different things, we've tried to have reusable configuration in the version stream, which does what we think you're going to need. And then if you need anything else, you can either modify these files directly, or you can add your own configuration files in addition. So if you look at one of these examples, let's look at how we've configured Tecton. So if you look in the version stream, so this is the Git repository version stream, charts, Jenkins X, Tecton, there we go. So Tecton, there's the defaults. There's a secret schema, which I'll maybe talk about later. Here's the values.yaml.template. And here's where we can take some default secrets. We can take, if we're using GKE, we can take the cluster name, or if we're using EKS, we can take the cluster name and the project name and add them as an annotation into the service accounts. So we can use these Go template expressions to conditionally change the configuration of the chart based on what kind of Kubernetes cluster are we using, what kind of ingress are we using, and so on and so forth. Are we using Vault or not? Are we using GSM or not, or ASM or whatever? So it lets us bake into the version stream the default configuration. So basically you don't need to touch anything, everything just kind of works. But if you really want to kind of peek behind the curtain and tweak things to totally suit your infrastructure, you can just use vanilla Helm file stuff to override the charts. And we've just finished. That's awesome. So that wasn't too bad. It was a few minutes. We've now booted. The boot job is completed, and everything is looking great, which is awesome. So as you can see, we've got a whole bunch of pods running and things. If I look at the repositories tab, we'll see we have a single repository. So this is the cluster repository. This is, if you like, the dev environment. Traditionally with Jenkins X, we used to have a dev environment, a staging, and a production, and each one would have its own Git repository. With Jenkins X version 3, we're currently just using a single Git repository per cluster. So if we decide to have staging and production inside the same cluster, but just in different namespaces, we'll still use this single Git repository, which we'll see in a moment. So now let me create a new quick start. Let's make the window go. There we go. Let's create a new quick start in here. So we use a command called project, JX project in Jenkins X3, and there's a quick start command. So JX project quick start. And I'm going to pick a Node.js example. And I'm going to use my usual Git user. I'm going to use my personal user to rather than the GitHub organization for now. And I'm going to think of an awesome project name. So this is going to create a brand new Git repository. If you've seen Jenkins X before, this is going to look familiar. It's pretty much the same. One slight difference is it prompts you to define which build pack library to use and which folder or style of build pack to use. In this case, I'm going to use the JavaScript style from the default build pack. So I'm going to create a Git repository. Just while that's going on, I'm just going to flip to the pipelines tab in Octant so we can see the pipelines when they start. And I'll close these windows down. So now it's created a Git repository. Let's look at the Git repository. For those of you who've seen Jenkins X before, this all looks about the same as usual. It's a normal Node.js application, nothing too exciting. It's just a fairly simple bit of Node.js, which renders this rather awesome HTML page. And there's a Jenkins X YAML in there and so forth. One difference the eagle-eyed amongst you might have noticed is the pull request we've generated now to import this project is a little bit different to normal. So what we've done is we've created a new Git repository called Awesome Nodey. And we've now created a pull request on the cluster Git repository. And we should see a pipeline starting. You see there's a pipeline started there. And there's a pipeline started running on the cluster Git repository. Now, let me show you what that looks like. So we've done a small commit. So we've added to this dependency matrix file, which just keeps track of all the different Git repositories that we're using so that we can keep track of the flow of versions across things. So we've added a new dependency to the dependency matrix, which is just metadata really. We don't really use that for anything definitive. But we've added this new config file. Let me view that file as a single file. We've got this new config file called source config. Now, this is a simple YAML file which has schema and reference documentation of how this works and everything. But basically it allows you to define one or more groups. So here I've got a group with an owner, a Git provider, in this case github.com. So if you like, this group is for this URL, github.com/jstrachan. It's basically that URL. So it's basically my Git repository. It's the repository in my personal user account. So it's these repositories. And then inside the repositories element, we can add 0 to many Git repository names within that group. So basically, this is just a simple canonical file at this canonical location, .jx gitops source config. And inside that file, we can just add as many repository names as we like. So it gives you a really simple way of just editing this file with GitOps is a way of importing new repositories, which is pretty cool. Now, what's interesting is we found ourselves, we needed to migrate from version 1 to version 2 of Jenkins X and then from version 2 to version 3 of Jenkins X. And whenever we do a migration, we need to migrate repositories from one cluster to another or one installation to another. We have a handy little, if we go into the JX CLI Git repository, in the JX CLI repository, these are all the plugins. And if I look at the GitOps plugin, the GitOps plugin has a command JX GitOps repository export. If I look at that one. So if you basically connect to a version 2 cluster or an old version of v3, and you run this command JX GitOps repository export, it basically generates this file for you. So you connect to your old cluster, run this command, and it basically creates that YAML file with all the source repositories in there. You can then do a pull request on your new cluster to just import all the repositories in one go. So it gives you a really simple way of exporting all of your source repositories and importing them into another cluster, which is nice. So we did that ourselves to migrate our infrastructure from version 2 to version 3. So we just did one pull request to merge this one file across, and boom, everything was imported. Okay, so we're back on this Git repository. We've got a pull request. This piece here is a little bit slow, I confess. What happens, we create one pull request, which is a fairly small commit. It adds the source config repository. Then a pipeline runs, and then it's going to create another commit in this pull request to add all the rest of the configuration. So in Jenkins X, we have a whole bunch of configuration around source repositories. So once we know all the source repositories are, we create a source repository custom resource for each repository. And we also create Lighthouse configuration for all of the pre-submit and post-submit pipelines for that repository. So any second now, we'll get another commit on this pull request, which is going to be all of that extra metadata that we generate for each imported project. And so I'll just wait for that pipeline to finish. We'll just leave it running. I'll leave it on this screen so we can see what the pipeline's actually doing. So the very, very first time you import a project in a completely empty cluster, it does take a little while. It's got a few images to download. It runs the pipeline a couple of times too many. But once you've imported one project, it's much, much quicker. I'll just see if there's anything in the chat. Well, I'm just waiting for this bit to work. No, nothing in the chat so far. Feel free to type any questions in the chat if you've got any questions about anything I'm showing. So once this pull request does merge, it should merge soonish. Oh, we're getting closer. What's going to happen is the pipeline is going to run again in the master branch of the cluster Git repository. And that's going to update the Lighthouse configuration so that Lighthouse knows about all of this new Git repository. It's going to register all the webhooks so that whenever we do a pull request on this Git repository, it's going to trigger pipelines and so on and so forth. Now, this whole process right now is a little bit slower than it used to be in Jenkins X v2. But the really nice thing is there's only one way of doing things now in version 3. So whenever you change the Git repository in any way, it runs the same job, defined in the same way inside Kubernetes. So we're all going to share the same job definition. It's not going to be dependent on which version of Git or kubectl or Helm or whatever is installed on your laptop. Everything is run inside Kubernetes using a canonical job definition, which is going to be the same for everybody. So we're all going to be sharing the same stuff. We've had so many issues over the years with slightly different versions of different command line tools on different people's laptops. The great thing now is you modify Git and then Jenkins as a canonical job inside the cluster and everything's kind of cool. So in a few minutes time, this should work. Great question, Jeff. Is the process to install on-premise or an existing Kubernetes cluster the same? What we're trying to do, I mean, we've tried to do many things with Jenkins version 3. For me, one of the biggest changes of version 3 is we're trying to make it easy to customize. We're trying to make it so it's flexible so that you can do whatever you want to do. We were just chatting on Slack this morning. Let me just show you the repositories view again. If I just show this Git repository, we were just chatting on Slack earlier that someone said, oh, I'd like to not install Tecton. I'd like to install Tecton a different way. So I'd like to install Tecton by hand. Or another common question we get asked is, I'd like to not install Nginx. I'd like Jenkins X not to do that because someone's already installed Nginx for me. Or I'd like to use a different namespace or change a repository or whatever. So the lovely thing about Jenkins X version 3 is it's literally all in GitHub. So just change anything you like in this file, in this Helm file. You can delete things, you can add things, you can customize things. So it's really, really easy just to configure and tweak to do exactly what you need to do. Because it turns out that a Google installation versus an Amazon installation versus an Azure versus an on-premise installation versus a kubeadm on Amazon versus Minikube versus Docker, they're all quite different. And you are probably going to want to do different things with storage, different things with your repositories, different things with your container registry, different things with ingress. And so rather than kind of Jenkins X owning that stuff and doing kind of weird magic. Now Jenkins X just says, hey, just edit this Helm file. It's a canonical standard file format. Just edit the Helm file to do whatever you need for your cluster. What we hope to do, we hope to make it much easier for folks to configure Jenkins X on different clusters, and we want to make a SIG to help people do that and share kind of approaches and techniques for doing this. And ultimately, we would like a quick start for a vanilla Kubernetes install. Right now on the Jenkins X website, if you go into the docs and into 3.x and guides, sorry, getting started. Currently, we only have GKE, EKS, and Minikube as examples, but Minikube is effectively an on-premise installation. Minikube doesn't assume anything on Google or Amazon or Azure, so there's no cloud buckets, there's no cloud service accounts, there's no cloud container registry. So Minikube is maybe not a bad place to start doing an on-premise installation. The trickiest thing with on-premise, well, there's lots of tricky things with on-premise, but the trickiest piece is usually the container registry. If you're on-premise with Kubernetes and you want to be able to build container images yourself, you typically want to be able to deploy new images into a container registry that you can also pull images from that registry inside the Kubernetes cluster. And depending on the on-premise installation of Kubernetes, you sometimes need to tweak your kubelet nodes a little bit. For example, if you don't have TLS set up for your container registry, then you need to enable insecure container registries so that the kubelets can pull the images from inside the container registry nicely. So it can be a little bit kind of fiddly. We obviously want to make it as easy as possible for folks to get started on any kind of cluster. So we're hoping to do a better job of quick starts and guides and so forth to help you walk through that. Now, one of the interesting things about the new v3 install mechanism is we use these template repositories in this organization. Let me just show you. So we have a GitHub organization for all of these different templates to start with. So here's the Cube template. This is the EKS Terraform example. This is a GKE Terraform. So if anybody is trying to optimize Jenkins X for a very specific cloud, a specific cloud provider, a specific Kubernetes installer, like maybe a kubeadm or something like that, or kubespray, anybody can create one of these Git repositories and try it out themselves. And if it works well, we'd like to, and you're willing, we'd like to contribute it into this repository, and we can build up a large repository of example starts. We're hoping to make it easy to automatically test any of these repositories so that we can keep all of these repositories tested and we know they work. And ideally we'd have two organizations, one of the tested ones and one of the ones which are not yet tested and so are kind of experimental. So hopefully we can really innovate as a group to make it easier to have out-of-the-box configurations for different kind of clusters. It doesn't quite work yet, but we've got a Docker example. Turns out Docker is slightly complicated to use right now, as in using Docker Desktop. So at some point, it would be nice to support Docker Desktop. Right now, if you're on a laptop and you want to run it yourself, try out the Minikube example. That works pretty well. And there's instructions on how to do that here. But yeah, great question. Yeah, I'm just catching up on the chat. Right, yeah, there's some great questions there. Let me just talk about the questions. We'd love to provide JX3 for micro Kubernetes and for anything, kubeadm, pretty much any form of Kubernetes that's out there that people like. We'd like a nice OpenShift integration, we'd like a nice Pivotal integration. Pretty much we'd like to integrate with pretty much everything, and we want to make it easy for you to do that as well. One of the big changes, if I just look inside the source code for a second, one of the things that's really nice about the new installation mechanism is we generate all the YAML for all the resources in Git, so that you don't really have to think about things like Helm or Customize or Kept or Helm file or all these kind of quite complex tools. You can just look at the YAML. So let me show you, for example, let's look at Nginx. Here's Nginx. This is the Nginx deployment. So this is the exact resource which is going to be applied to Kubernetes. So we can see these are all the labels, these are the annotations, these are the containers. So you can, it's very easy for anybody just to look in Git and see what's actually running in Kubernetes, rather than looking at a Helm file and you have to squint and totally understand how all the magic happens in kind of Helm file and Helm and all those kind of things. In addition, we have a simple makefile. So if you look at the top level, there's this makefile that just includes this file in the version stream, which if I just pop and look at that, we've got a very simple makefile that just runs a whole bunch of steps. So look at source, makefile.mk. And this is a fairly big file. It's like, I don't know, 200, nearly 200 lines. But basically, this is the steps that are used to install Jenkins X. So if you wanted to do something different, you can just put it right here. So for example, we use a step here to do JX GitOps Helm file template. So basically that step runs Helm file template to generate all of the resources from the Helm file. Now, if you wanted to do something else, something before, something after, something instead, something with, you can just add different steps in here. So you could add your own vanilla Helm install commands if you wish, or you could add your own, you could use customize to modify the output of the Helm template. You could use tools like kept. We have a bunch of our own tools that do various things, like we have a generic tool that will add labels to things. We have a tool which will add annotations. We have a little tool that will add a hash value to force rolling upgrades. Incidentally, here's another thing we do. Where was the label? Yeah, this one. This step adds an annotation to all deployments, and it adds that annotation to all deployments, which if I go back to look at Nginx a second, so I'll show you how that looks. So if I look at Nginx, config root namespaces, Nginx deployment, we'll see that there's an annotation with. Now, what the annotation does is there's a tool called pusher wave, which it watches all of your deployments. And if it sees a deployment with that annotation, it will look at all of the secrets used by that deployment. And if the secret value ever changes, it will automatically do a running upgrade of that deployment. And what that basically means is if you modify any secrets in Vault or whatever your secret store is, pusher wave will automatically do an immediate rolling upgrade of that service. So if any actual secret value changes, all deployments do a rolling upgrade, which is a really, really nice thing. Because very few people think of doing that. You can do that kind of stuff with just vanilla Helm. It's quite common in Helm to say, generate a hash annotation based on the secret value. But if your secrets are being populated directly from, say, Vault or Google Secret Manager, Amazon Secret Manager, you're not actually running Helm every time your secret changes. You could change your secret much more quickly. So this is a really nice little feature that lets us have rolling upgrades when secrets change, but just using the simple steps in a makefile. So you're free to take this file and play with it, tweak it, configure it, do whatever you like with it. We obviously want to try and keep people using a fairly similar version of this file so that we know things work. But there's nothing to stop you doing additional steps to do different things. But we obviously hope that the default works for everybody, so you don't have to do too much kind of customization. There was a great comment from Gerd about architectural overview of all the dependencies. Let me quickly show you. If I pop to the pipeline page, by the way, we'll see the import finished. I should have mentioned that. We've done the import, so that pull request did merge. Let me show you the pull request, actually. Oh, I got choking, I forgot to show you. So we created a pull request that's closed now, this one, this pull request. So this was the pull request to add the new Git repository. And you'll see the initial change. You'll see the initial change was fairly modest. It just added the source repository. It just added that. Then another commit was merged, which did a whole bunch more changes. So this changed the Lighthouse configuration. It added a source repository custom resource. It added the post-submit and pre-submit section to Lighthouse and so on and so forth, and various other bits and bobs. It configured which plugins to use in ChatOps for that repository and so forth. So it generated a whole bunch of extra stuff for us, which is great. And then that's now merged, and the pipeline is now running for awesome Node, which if I click on that pipeline. This is the quick start we created. It seems quite a long time ago now. The pipeline's almost finished. You can see it's created the pull request. If I click on this link here, that's the pull request. So this is the pull request now to promote version 101 of this awesome Node quick start, which if I look at the files changed, the same kind of thing has happened here. The very first commit was small. So the very first commit literally just added a new entry into the Helm file and added a new Git repository, because we've never used this Git repository yet. That's the local chart museum. So it's added the local chart museum to the Helm file, and it's added one chart into the Helm file. And it said use the namespace JX staging. So it's using the staging namespace, it's specifying the version of the chart, and there's the chart version. So that was a fairly modest pull request. Then since that's gone in, another commit happened automatically, which generates all the actual resources that that change means. So this is the effect of that change. So it's creating a new namespace because we'd never used the JX staging namespace before. So it's created a custom resource, well, a Kubernetes resource for the namespace. It's created the deployment in the staging namespace, and it's created an ingress so that we can access it. That's the host it's going to be accessible as, so we've got the new ingress to use. And it's created a release custom resource, which is basically a bit of metadata Jenkins X provides, so you can know what's the git commit SHA of this release, what's the git clone URL, and where's the release notes defined, and so on and so forth. So that's the URL to the release notes. If I click on that, we'll see the release notes for that release and so forth. And there you go, there's the release notes. So we can see exactly what happened in that promotion. That promotion is just about finished. So that promotion has now triggered a pipeline on the staging, on the cluster repository. That pipeline should merge fairly soon, and then we'll have promoted that, that app into the staging repository. Just while that's running, I'm just going to do trigger a preview environment as well, just to show you how that works. I'm going to, sorry, repository. So let's click on this Git repository. This is the quick start I just created. I'm just going to edit this file, and I'm going to create a pull request. So I'm going to say Jenkins X is awesome, and I'm going to say fix more awesome. I'm going to create a pull request. So I'm going to create a new change to the home page. Create a pull request. And if I click on the pipelines page, we should see the pull request pipeline start. You see that's triggered off there. We can filter this page if you just want to look at only the awesome Node stuff, which is a bit easy to read. So we can see that the release pipeline is completed. We've created a pull request on staging, and that's triggering along now. We've now got a pipeline running to create a preview. Yeah, great point, Ankit. Let me show you, by the way, the apps page. The apps page shows all the apps that are installed in the development namespace. Chat Museum, we've got the Git operator, we've got these two controllers that handle builds and roles, and Foghorn, Controller, Keeper, and Webhooks are all components of Lighthouse. We've got Nexus and we've got Tecton. There are lots of different permissions you can use with Jenkins X. So you can get rid of Nexus if you don't need it. You can get rid of Chat Museum. You can use something called Bucket Repository instead. So you can kind of tinker with some of these core pieces. The stuff you absolutely need though is Tecton and Lighthouse to be able to do CI/CD and to be able to do chat ops and so forth. A quick question that came up about multi-cluster. In the previous JXL release, we deployed into staging and production clusters, remote clusters. We deployed Lighthouse and Tecton. It turns out for a remote cluster, we only really need the Git operator. For actually just to do a deploy of whatever's in the master branch, the Git operator is literally one pod. So it's really small, it's really simple, and that just runs a job whenever the Git repository changes. So for multi-cluster, in the remote clusters, we only really need to install the Git operator. We don't need to install anything else. We don't need to install Nexus or Chat Museum or Tecton or Lighthouse or any of those kind of things. We can run the chat ops and the pull requests and all of that kind of stuff. We can do all of those operations on the remote clusters Git repository. in the same cluster that we have Lighthouse installed. So we can run all of our pull requests and our chat ops and stuff in the same cluster, in the development cluster. Then in the remote staging or remote production cluster, we just run the Git operator, and that's enough, really. So we can have a really simple cut down version of Jenkins X in staging and production if it's remote. If you really want, you can run Tecton and Lighthouse there. There's nothing stopping you. You can run anything there you like. So you could choose to run Nginx there if you wish, or Istio, or whatever it is you wish to use. Hopefully the promotion should have finished by now. If I pop to the staging namespace, you see we've now promoted Awesome Nodi version 101 to the staging namespace. And if I click on this URL, you'll see, hello world, woohoo, it's working. So we've done a deployment, that's awesome. And you'll see the pull request I created. You'll see we've got a comment on the pull request. The pull request is built and available in the preview environment. And here's the preview environment. And there's Jenkins X is awesome. It's working, the preview works. Incidentally, if you're looking at pipelines in Octant, if I look at the pipeline view and I'll filter again just on, oh, sorry, I'm in the wrong namespace. Let me go to the JX namespace. And we filter on Awesome Nodi. If I'm looking, you'll notice from this page, we can see that there's a promotion pull request and there's a preview. So just from this page, I can zoom straight into the pull request. So I can say, what's the pull request that did the promotion? There it is. Or I can say, what's the preview from here? So I can go straight to the preview app. Or we can look at those things from the pipeline page. So if I'm on the pipeline page, from here, I can click straight through to the preview here. That's the preview. There we go. Or we can look at the pull request that made the preview. So then I can see this was the pull request that made the preview, and I can see what were the files that were changed, or I changed the homepage, and so on and so forth. And we can see obviously the repository as well, so we can navigate there. So the Octant UI is really useful. You can pretty much navigate anywhere you need to look at just from this one page, which is awesome. New modular approach to J. I was hoping for more simplification and clearer supervision of concerns. Good question. I'd be interested to know how we could make it more modular and more simpler. For example, the JX CLI is now completely modular. So here's the JX CLI. The JX CLI itself, the JX binary, has virtually nothing inside it. All the real work is done by these completely separate plugins. So all of those GitOps commands you might see in the pipeline is a completely separate binary. It's got nothing to do with the JX binary. And this JX GitOps binary is a thing that does those GitOps operations. So we have a separate binary for doing the administration, installing and deleting. The GitOps operations, working with Jenkins servers, working with pipelines, working with preview environments, doing promotions, creating or importing projects, working with secrets, working with test environments, and verifying installs. So they're all completely separate binaries, completely modular, completely separate. Each can go at whatever cadence it wishes and so forth. Quite a lot of these don't even use the Jenkins X Git repository. If I look at the secrets, for example, this is the secret plugin. The secret plugin takes care of working with something called external secrets. If I do JX secret verify, oh, I haven't installed this plugin, it's just downloading. So the first thing to note is when you install JX, by default, it doesn't install all the plugins because they're installed and managed separately. So the first time I've run JX secret since I upgraded JX, so it's now downloading and installing the JX secret binary. This is now listing all of the external secrets and whether or not they're populated. So this is letting us see, we populated most stuff, but we haven't defined a release GPG key and we haven't defined a node NPM token. How this works is there's a CRD called external secrets. There's a CRD for external secrets, and each one of these, I'm not going to show you what's, well, I'll show you one of them. Let's look at the Lighthouse. kubectl get external secrets, lighthouse.yaml. So this is showing you what is the status of the Lighthouse OAuth token. That's the schema to validate it, and this is where this is the location in Vault where we're going to load the secret from. So external secrets lets you map from vault locations to Kubernetes secrets and takes care of all that for you. But the JX secret CLI is a complete standalone binary that's got completely decoupled from JX. So from a CLI perspective, everything is kind of modular, everything's simple. Each one of these things has really good code coverage. It's very easy to look at one of these modules and work on it independently from all the other ones, and so on and so forth. So from a JX CLI and binary perspective, everything is now completely modular. From a chart perspective, the basic pipeline that installs Jenkins X is pretty open and it's defined in Git. Let me show you a bit more about the Git repository. I'll show you repositories. I'll show you this is the Git repository. So the Git operator is this tool that runs jobs whenever this Git repository changes. The job that runs is defined in this YAML file in here. So in version stream git operator job.yaml, this is the job that runs whenever Git changes. And it's just a simple piece of declarative YAML. So it's completely loosely coupled. You can modify this to do whatever you need. Right now we use the JX CLI. We use the JX CLI, and we run a fairly simple command called make apply. And that uses the make file to do whatever steps you define in your Git repository. So again, it's completely open, it's completely decoupled. You could use any steps in your make file. You could use any image you wish. You could have multiple steps and so on and so forth. So in many ways, we've decoupled the boot process into something that's simple and generic and loosely coupled and something that anybody can modify and do whatever you like. Is it possible to make a minimal setup and then add the components if necessary? Yeah, that's a really good question. Which components are essential? Well, the interesting thing is the only thing that's essential is the Git operator. Nothing else is. But it depends what your cluster is meant to do. For a development cluster, as in a cluster that's going to do chat ops, is going to create Git repositories and do releases and those kind of things. For a development cluster, we need a container registry to store images, which could be hosted externally. It doesn't have to be inside Kubernetes. So that could be an external container registry. We need somewhere to release Helm charts to. And again, that could be something external, so it doesn't need to be installed. There are various different options you could choose for those two things. The bucket repository is one option for those two things. You could have external container registries, external chart repositories. And we absolutely need Lighthouse for chat ops, and we absolutely need Tecton to run the pipelines. That's pretty much it. But for a remote cluster, so remote staging, remote production, you only need the Git operator. You don't need anything else because in production, you're not creating container images from scratch. You're reusing existing container images. So it's fairly flexible, as in you can choose which components you wish to use, and you can opt in and out of different things. You can opt out of Nexus. So if we look at the, let me show you the Minikube config. Here's Minikube. If you look at the Helm file for Minikube, you'll notice there's bucket repository, and there's no chart repository, and there's no Nexus. And there's a Docker registry as well. There you go, there's Docker registry. So we specifically configured a different configuration for Minikube to make it small. If you're running Kubernetes on your laptop, most people's laptops doesn't have a ton of memory. So we've tried to make a small installation for Minikube. So you can get the full effect of Jenkins X. Everything kind of works, webhooks, everything, chat ops, it all works in Minikube. But we're not running Nexus because Nexus is fairly big memory-wise. And we're not running Chart Museum as well, which is slightly bigger. We're just running a bucket repo, which is a fairly small, lean, mean piece of Go. It could be that you don't even need bucket repository and you might be using, I don't know, GCR or ECR directly. And you might want to use, say, GCR or ECR or ACR as your container registry. So you might not even need bucket repo. You could just use the cloud storage directly. So yeah, I think just to Gerd's questions, I think we should do a much better job on the website describing which components are required or mandatory for different kind of uses. For example, Nexus. If you're doing Java or with Gradle or Maven or something, Nexus or Artifactory or something like that is pretty handy. If you're not using Java at all, and you're just using, say, Go or Node, you probably don't need Nexus, and you can probably get away without doing it. However, if you're using Node, often people release Node packages and NPM modules using things like Nexus. So it does slightly depend on how you want to do your releases as to which of these software tools you need to pick. I would love it if one day we had an amazing like web UI that let you kind of pick and choose which extra add-ons you wish to use. But we should maybe at some point have like a really cut down minimal getting started Git repository, and then a kind of a full, maybe we could have a Java developers version versus a Node developers version or something like that, because some of these things are completely optional, like Nexus is a definite optional thing. If you're using Go, for example, you never need Nexus for Go. You can just use your Git repository and container registry and a place to put your Helm charts. Helm charts, by the way, longer term, it seems like the Helm community are looking at using container registries to store Helm charts. It's taking a little while to get there, though, and to get all the container registries supporting Helm. It might be nice at some point to use the Git provider as a Helm repository. Just so then there's less components, right? If we could just have the Git repository and container registry, and that's it, that simplifies the install of Jenkins X. But yeah, I agree, good. We should be able to document this much better and make it easy for people to pick and choose. Only install Nexus if you're releasing Java stuff or you're using NPM modules that you're releasing. Otherwise, don't worry about Nexus, and so on and so forth. If memory's tight, use Bucket Repo. You generally, if you're using an external container registry, you don't need to install a Docker registry locally, and then so on and so forth. So yeah, we definitely need to do a better job. And another thing, by the way, these three things, if you're using Google Secret Manager or Amazon Secret Manager or Azure Secret Manager, you don't need those three charts. So those three charts are, well, actually, those two charts. Those two charts are literally there to deal with Vault, which is one secret storage solution, but there are other secret storage solutions that involve a smaller deployment. So yes, we're going to be doing lots more demos and videos and docs on all of this stuff. It's still fairly new. It worked, which is awesome. But hopefully we can do a much better job of getting people started on version 3, and particularly getting people started on version 3 in different kinds of clusters. We've never done a great job with on-premise. On-premise can be quite challenging. So hopefully we can do a better job helping people get started with on-premise Kubernetes clusters. Any other questions? We're almost out of time. I'm glad the demo actually completed in time. So yeah, I think, or another thing that I think James Rollins is on vacation at the minute, but I think maybe he was looking at the next office hours to do a demo. When you're using Terraform, the Terraform uses a state storage to store, what clusters has it made and what buckets has it made and so forth, so that it can, next time you run Terraform, it knows, do I need to change anything or add anything or remove anything or whatever. So strictly speaking, when you're using Terraform, you shouldn't just use the local file system as the state file, which is what I did in my demo. If I look at my file system, I've got the Terraform state file here because I'm not using like a bucket or something. So strictly speaking, you're meant to set up a bucket with Terraform. And then if you had, say, 3 clusters, that's 3 buckets. So that's a whole bunch of stuff you have to set up before you can even run your Terraform. James has been looking at using Terraform Cloud, which is like a little SaaS-y kind of hosted version of Terraform that just lets you import your repositories, and it just does the state for you. And it just means that you can have real multi-team Terraform out of the box without actually setting up any infrastructure, which is awesome. So it just means you literally just import your Git repository into Terraform Cloud, and it just basically works. So I think that could be the easiest way of getting people started, particularly with multi-cluster. With multi-cluster, where you want to spin up 3 clusters, you probably want to have a real multi-team way of doing the Terraform side of things. So hopefully James can do a demo of that soon. No problem at all about that, good. We love any feedback. We love criticism. We want to make everything more awesome all the time. So if you can think of any way we can improve anything, just shout. I'm sure over time we'll think of different ways of making like the makefile easier to modularize or tinker or tweak, or making it easier to plug and play tools like kept or customize or whatever, or to make it easier to use different HAM files side by side or whatever. So I'm sure this is just the start of V3. We can keep improving. Yeah, Atlantis is also pretty good. I really like Terraform Cloud though. They've done an excellent job on Terraform Cloud. It's really slick. But yeah, absolutely. There's also the option that you use your cloud provider's CI infrastructure. You know, Amazon, Google, Microsoft all have CI engines and build stuff built in. The only slight complication in that is to set up CI in Amazon, Google, Microsoft, and the bucket to be able to run Terraform. You then need a lot of infrastructure to set up to be able to run Terraform. So it's one of those kind of chicken and egg. You need a whole bunch of Terraform to make the Terraform stuff so you can run Terraform. The lovely thing about Terraform Cloud is you don't have to set up any infrastructure. It just kind of works because they've solved the CI and the state problem. Hopefully the cloud providers will kind of learn from the Terraform Cloud UX and maybe have something similar someday, because that would be really nice. It'd be lovely if you could just basically point at a Terraform Git repository in, you know, on the Amazon console, on the Google console, on the Azure console, and for it to just do the Terraform properly for you without you having to, you know, run a lot of commands to boot up, you know, create, you know, service accounts and IAM role bindings and buckets and CI jobs and wire everything together. We want a nicer getting started experience. Yeah, one of the important things, by the way, is this is an alpha of V3, right? This is our first guess of what we think would be great for version 3. We really want your feedback. We want to know what you like, what you don't like, what you think could be improved. Could we do things differently? Is there anything missing? Should we do things a different way? Would you like to see things done in it? You know, whatever. So please think, have a look at everything, kick the tires, play around with it, see what you think. And if there's anything you can think of that we can do better, anything we can improve, we would love any feedback at all. So please, yeah, the more feedback, the better. And please don't worry about criticizing anything. We love criticism. Try and be kind, but really we'll take any criticism at all, honestly. Please don't be shy and don't worry about hurting anybody's feelings. We know everything can be improved, right? No matter what you do in software, you can always think of a way of making it better. So please just give us some feedback. That'll be awesome. So I guess I should start wrapping up. I've kind of run a little bit over, so apologies for running over. I'll try and do a more concise video at some point. But if you have, you know, colleagues or whatever who want to get started, watching the whole hour might be a little bit too much. So I'll try to do a shrunk down version that's maybe 15 minutes or something. But yeah, keep the questions coming. We're hanging out on Slack, so let us know what you think, and see you at the next office hours.
Bye.